press and make another.
Go.
The other aspect we want to look at is substitution now in logarithm. What do we call substitution in logarithm? Substitution, by definition, will just be when you replace one figure with the other. That is what we call substitution. You replace one figure with another figure. That means you have substituted the second for the first. Now, if that is the case, the process that is involved in the substitution here becomes breaking down the logarithm. There will be a particular log that you have to break down. When you break that particular log to the least or the lowest term, you now substitute the values that are required. So the first thing is to break down the log. When you now break the log down to the least term, you substitute. Pause. The examples under substitution, when you now want to do substitution, I said is the process of breaking the log to the least term, thereafter substituting. Those are the steps. You first break the logarithm and then you substitute the lowest term. They are now saying that log 2 base 10 is 0.3010. If you have calculator, very good calculator, you do that. What you just do is just press log 2. Forget about the base 10 here, just say log 2, you can get 0.3010. Also just press log 3, you can get these figures. So they are now saying log 2 base 10 is equal to this, log 3 base 10 is also equivalent to these figures, and all the respective figures are provided here. They are now saying you evaluate the following without using tables. These are past questions. The first one is log 12 base 10. Now, what are the steps involved? You break the log down. You break the log down, the particular value, you break it to the least term. Thereafter, you substitute. How are you going to break 12 down? You can break this 12 by looking at the figures provided here. What are the figures provided? The figures provided are 2, 3, 5, and 7. That means when you want to break log 12 down, you only look at these figures provided. 2, 3, 7, 5. Only, and no other figures from elsewhere. So you can only break the log down depending on the figures provided. Now, if I want to get 12, depending on the figures here, 2, 3, 5, and 7, how can I get that? Simple way to get 12 is to just say 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. Because they provided 2 here, they provided 3. I will not leave this one and say 12 is 6 times 2. 6 was not provided here. They did not provide log 6. So that cannot work. It can't. So if that is the case, the base 10 is here. Anytime we have multiplication, we say we add the logarithm. So because of multiplication here, I will say log of these 2 base 10 plus. Because of the multiplication, I add these 2 base 10 plus log of the 3 base 10. Now we substitute the values given. They said wherever you see log 2 base 10, you put 0.3010 plus. This one also is 0.3010 because it's still log 2 base 10. Then log 3 base 10 appears as 0.4771. So if we add these figures, 0.3010 plus 0.3010 plus 0.4771, that will give us an answer of 1.0791. That is the answer to that.
Pause.
The second question, the second past question says log 35 base 10 minus log 6 base 10. Log 35 base 10 minus log 6 base 10. Now we are going to substitute the values. Substitution is the process of breaking the log to the least term. You break them down. How are you going to break 35? When you want to break 35, you look among these figures. What are the figures, the numbers here you multiply to get 35? Simple figures I will multiply to get 35 among these ones will be 5 and 7. 5 and 7 were provided. I will not take numbers that was not given to me here. I have 5, I have 7. So for me to get 35, I will just say log of 5 times 7 base 10 minus for 6. Two numbers that I will multiply to get 6 that are among these ones are 2 and 3. That becomes 2 times 3 base 10. Now because of anytime you see multiplication you add, that is given us log of 5 plus log of 7 that way. base 10 here, base 10, common to them, minus. Because of two figures, anytime you write minus and two terms are to follow, you open bracket. That is the troublesome part of the whole thing. Anytime you want to write two terms, and that one is joined or linked by a minus, you open bracket. Now in this case, I have multiplication sign here. Since I have multiplication sign, I'm going to add. We have log of 2 base 10 plus log of 3 base 10. Because of the two terms, we have two terms. That is why this minus is there. If it is not there, the minus will only affect the first one. You get everything wrong. Now let us substitute. According to them, they said wherever we see log 5 base 10, we put 0.6990 plus. They said wherever log 7 base 10 appears, we put 0.8451 minus. Wherever we see log 2 base 10, they said is 0.3010 plus. Wherever we see log 3 base 10, according to them, is 0.4771. Now let us substitute here and see. We have 0.6990 plus 0.8451. That will give me 1.441 minus. Let us add the figures in bracket here. 0.3010 plus 0.4771. That will give us a figure of 0.7781. Now you are seeing subtraction. That means you are subtracting this figure minus this figure. 1.5441 minus 0.7781. That will give us an answer of 0.766 as an answer. The third question is saying we have log of 0.72 base 10. Now we said substitution is by breaking the log down. And how are you going to break decimal? If you recall primary school principles in converting decimal, anytime you have decimal number, you divide that by 1. Anytime decimal number appears, you divide it by 1. So if that is the case, this one that I have, 0.72 base 10, I will divide it by 1. And now move the decimal places. I have to move 1, 2 to the right. I will move the decimal point. There are two numbers after decimal point, so I will move 1, 2. The moment I have moved 2 places, I will come to the one I add 2 zeros there. So what we are now getting there is log of 72 divided by 100 base 10. That is what you get. At the end of the day, again, if you divide 72 by 100, you get 0.72. Now we break the log down. The rule says anytime you are dividing log, you subtract them. So if that is the case, I have log of the figure that is at the top is 72 minus, because of the division, log of the figure down here is 100. The base here is 10. The same base is common to the 2. Now we have to break these figures down. How are we going to break these figures down? For 72, I believe 72 is 9 times 8. 9 times 8 is 72. 9 times 8. But if you look at the details that were there a few minutes ago, there was no 9. There was no 8. How are you going to get 9 now? But 3 was provided. 3 was part of that set. So if we have 9, we want to make use of 3 out of 9. We say 3 times 3. So the 9 becomes now 3 times 3. We are done with that. Times the 8 is the same as 2 times 2 times 2. Because 2 was also provided. We are making use of the figures that we are provided. 3 was there, 2 was there. So for 9, it is 3 times 3. For 8 is 2 times 2 times 2. So if that is the case, we have the right now to say log of, instead of 72, we now say 3 times 3, that is 9, times 2 times 2 times 2. So what does that mean? 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. 36 times 2 becomes 72. The base is base 10. Minus log of 100 is the same as 10 times 10. 10 times 10 is the same as 100, base 10 here. We proceed. Because of multiplication, we are going to add all the log values here. We add all of them because of the multiplication. That is log of 3 base 10 plus log of 3 base 10 plus log of 2 base 10 plus log of 2 base 10 plus log of 2 base 10 minus, because we have two terms here, we open bracket. We have log of, because of multiplication you add, log of 10 base 10 plus log of 10 base 10. We now move. In mathematics, if you say x plus x is 2x, a plus a is 2a. So if I say log 3 plus log 3 is 2 log 3, because there are two of them, base 10, plus log 2 plus log 2 plus log 2, there are three of them, it becomes 3 log 2 base 10, minus into, when the log and the base they are equal, the answer is 1. So log 10 base 10, the answer is 1, plus log 10 base 10, the answer is 1. So if that is the case, we have 2 log of the values that we have a few minutes ago in the substitution case. They provided the figures. They said wherever you see log 3, the number that was there a few minutes ago, log 3 base 10 was 0.4771. So log 3 base 10 is 0.4771 plus 3 log 2 base 10 was 0.3010 minus into 1 plus 1 is 2. So let us now check this one. We have 2 times 0.4771, 2 times 0.4771. That will give us 0.9542 plus, when you multiply 3 by this value in the bracket, we have 3 times 0.3010, that is 0.903 minus 2. So if I now add this and this minus 2, I'm going to get 0.9542 plus 0.903 minus 2. That will give us an answer of minus 0.1408 as an answer.